Hello, everyone. So today we're gonna work on eBPF IPv6 clusters with Calico, and this is an early preview, like early preview. And I'm joined by Tomasz, um, and one of the maintainers of the eBPF data plane for Calico. Uh, Please go ahead, Tomasz, and introduce yourself for everyone.
Yeah. Well, thanks, Reza, for introducing me. I'm not sure I have much more to say. Yeah, I'm maintaining the Calico eBPF, and I'm happy to help Reza to showcase our upcoming feature that's going into the next release, IPv6 for Calico. IPv6 was definitely a feature we were missing for a long time, but later than never. And so we're going to have a preview version of IPv6 in eBPF in 3.27 with the goal of having general availability with the whole feature set in 3.28.
Great. So, from what I understand, it currently works on local environment, and you guys are working on making it work on all cloud providers. At the moment, EKS and AKS are a go. Like with the release, these two environments will work, right?
Yeah, I think there is way more environments that will work. There are some limitations which we will describe in our documentation. But the main limitation at the moment of the preview version is that if you want to use IPv6, then the cluster must be IPv6 only, pretty much. So we do not support dual stack. With that said, it is difficult to find a pure IPv6 deployment in public clusters and public cloud. So currently, we allow IPv4 traffic that has destination the node. So the nodes can be reached over IPv4, and the nodes can talk to the management of the cluster over IPv4. But the pods and the nodes, they all must have IPv6 address. For the nodes, they must have as well IPv6 address, but for the pods, they are IPv6 exclusive. So dual stack is definitely something that we want to have in the GA in the next release, but that is a work in progress. So you can definitely install IPv6 clusters with kubeadmin. You can install with kops. We have tried a couple of public clouds. I think Reza especially tried EKS. If you look at the Calico IPv6 documentation, it states that you should use Calico CNI to take advantage of IPv6. But we definitely know that, for instance, in EKS, you can make it run with EKS CNI. So yeah, there are some limitations. I think the other noteworthy limitation, except the lack of dual stack, is that we do not support do not track policies in this preview version yet. That's the XDP part of the data plane, and we haven't upgraded to IPv6 yet, but that's definitely coming into the GA version. So stay tuned.
Great. So let's start by running some codes. Oh, by the way, if somebody is curious to know how to run this, they can find everything here. Just everything is written. I'm gonna actually go ahead and copy paste code from this repository. If you guys got any questions, please shoot it in the chat. While I might not be able to answer your question, Tomasz is very capable of helping me, hopefully. All right, so a couple of things to mention. I'm gonna use Multipass for this demo. And regardless of what environment you're using, IPv6 is usually not enabled by default. So for instance, I have to fiddle with the configurations of libvirt first, or I will get an instance that is IPv4 only. So just to make sure we all find the problem first. Let's just launch a test pod or test VM to. All right, so multipass shell is the command to SSH into the pod. Let's just get rid of this. And if I do IP6 ADDR, there is only a link local IP address, which can work, but you need to specify the interface at the end. It's kind of a hassle. Let's just enable a proper private or local IPv6 address for our environment. Now, what I need to do is I need to edit. So first of all, if you do virsh netlist, you will end up with the networks that your multipass is using in Linux. I believe if you're on Mac, it should be enabled by default. If you are on Windows, it's going to use Hyper-V. You're going to need NetSH, but that's another story. So let's just try to edit this. So I'm going to edit the default. Now I need IPv6 here. Let me just find the nodes, and it should be IPv6, yes. And at the bottom, I'm going to add a range for my IPv6, which is the DHCP part. So I'm going to use FC00. These two columns means just fill it with 0, and the IP address for my host is going to be 1. The prefix is going to be 64. It's way bigger than IPv4, so we have 128 bits. So if you want to make it smaller, you can. So the range that I'm using for my DHCP allocation is FC002 to FFFF. Now, these IP addresses are going to be assigned to my nodes. Now, after you change this configuration, you need to destroy your default network. Don't worry about it. It has a bad name, but it does the job. Then you will start it again. Now, if you do IPv6 ADDR, you should be able to see the FC link here. Anyway, all right. Now that everything is set up, with the requirements, let's just run our first node, which is going to be the control plane. By the way, if you have any questions, just shoot it in the chat. If you like to know the commands, you don't need to write them down. Everything is transcribed in this URL. It's gonna take a couple of seconds for this instance to run, but let's just go over the command. So -c means how many CPUs I'm allocating to. Memory is going to be 4 GB for the control plane. I'm running K3s. It's not that resource hungry, so I can actually give it less, but again, it depends on your test environment. I'm using 15 GB of disk storage for this instance. And I'm using Lunar, Ubuntu Lunar, which is, I believe, 2304 or 10. I would say, yeah, 2304. The cloud init part is all the requirements and preparations that we built into a cloud init format. So if we come to our control plane, that cloud init has enabled the Kubernetes cluster for us. So there's actually a node already in there, no CNI. That's why you see the not ready part. You can actually verify it by tailing the container D. And other than that, there is one thing that I like to mention. So as Tomasz mentioned, when you're doing IPv6, you need to make sure that your nodes are actually running IPv6. Usually, everything is going to be by default dual stack because most Kubernetes distributions that I tried out will use IPv4, will prefer IPv4. Then if you specify it, will then and only then, if you specify it, they will go to IPv6. The way that you specify this is actually by, I believe, so in this environment, which is K3s, is going to be with this -- node IP in the system D. In most Kubernetes environments, it's going to be -- node IP, but the placement will be different. Some would take it from the config file. I believe kube-adm takes it from an argument. But anyway, just make sure that you see the documentation for your Kubernetes distro. And that IP address is actually my node IP address. Anyway, it's the FC one, not the FE8 one, because that is link local. All right, so next I'm going to add another node to my cluster. This is going to be a worker node. Again, nothing special. Again, it's going to be the same thing. This is the VM name that is going to be used. And which you will see in Multipass. 2 CPUs, 4 GB of memory. Again, everything the same, but the only thing that changed other than the name is the cloud init file, which has a lot of scripts to automatically join this worker node to your control plane. And when that is done, we can get to the fun part of IPv6. All right. At the moment, everything is in Multipass, but I want to use kubectl in my host computer. So what I'm going to do is I'm going to transfer or SCP the kubeconfig file from my control plane to my host. Then I'm going to get the IPv6 of that control plane and modify the Kubernetes config and export it so I can do kubectl get pods. And hopefully I will install kubectl first. It needs classic. So right now it should be able, it should be able to talk to the cluster. And as you can see, there is a control plane and there's a node, and we hit our first live issue. So that will be a guarantee that this session is actually live. Anyway, so right now, what I'm going to do is to install Tigera operator. I'm going to use the nightly image or the master branch. After Tigera operator is installed, we need to tell it how to install our Calico, how to install Calico for us. Now, one thing to mention here is that our environment doesn't have any sort of kube-proxy, because Calico eBPF data plane is a complete replacement for kube-proxy. You can tune it to be the main networking component, or if your environment doesn't allow the removal of kube-proxy, you could actually change the configuration to allow kube-proxy to work in a limited scenario, and Calico eBPF data plane will take up the rest and does the every sort of networking thing in there. Now, Tomasz here, I believe, can give you a better view of this sort of replacement for kube-proxy. Like, what are the stuff that we do?
Yeah, the reason why the eBPF data planes replace kube-proxies is that in the eBPF, the IP tables are often bypassed, and when the packet enters a node, it's sent directly to a pod. And so the generic kube-proxy from your Kubernetes distribution doesn't matter what it programs into IP tables, it will be bypassed and it will not take an action. And one of the big advantages of eBPF data planes is that this service implementation can be done faster. Imagine that you have a cluster where you have 10,000 services, and there is a list of these services, and you hitting something at the bottom of the list all the time, most of the time. So that takes time. While in eBPF, you can use a hash table instead of a list, and essentially get the same lookup time for any service, independent of where it is in the alphabetical order or whatever order. So yeah, that's I think the major reason why, two major reasons why kube-proxy is replaced. Speed and the fact that you would not get the benefits of eBPF if you were going through IP tables anyway. So yeah,
Right.
and then we can also interact better with our own kube-proxy. And that's a similar thing, not just for Calico, but other similar projects and products out there.
Right. So by default, when kube-proxy is enabled, your CNI, hopefully most CNIs, not all of them, will try to use the service IP and actually kube-proxy to communicate with the API server, because we don't have any kube-proxy, and we're going to put everything on our eBPF data plane, all the responsibilities on eBPF data plane. We're going to create a config map, a unique config map for the Tigera operator to know how to communicate with the Kubernetes API server directly.
Yeah, this is a bit of a chicken egg problem. In regular Kubernetes with regular kube-proxy, kubelet kind of takes part in breaking that cycle, but we don't have that. We already running in some Kubernetes that has been installed, so we have to break that circle in our own way, and we essentially need to tell our kube-proxy and our component, hey, this is the way how you can contact the API server without actually having the service implemented yet.
Got it. So now that we have solved the chicken and egg problem, we'll wait for the operator to try it another time. By the way, you can just go ahead and actually instruct the operator with another unique resource, which is the installation manifest. So in here, there are a couple of things that I would like to talk about. One is Linux data plane, BPF. So right at the bat, we're going to tell Tigera operator that this cluster is going to be using eBPF. And the IP pool, here, as you can see, I've added the CIDR for my cluster. This is different, if you remember, from the one that was assigned to my nodes, because again, pods are usually on a different CIDR. If you are using something like EKS and AWS CNI or Azure and Azure CNI, then you need to make sure that you are not putting IP pool here and actually telling Calico the CNI type is going to be Azure CNI or AWS CNI. Everything is documented in our docs website. If you like to know more about it, I believe it's going to be docs.tigera.io or info. It's going to be here. I'll find it. All right. So if you want to know how you can actually chain Calico to any other CNI, some like AWS CNI or Azure CNI. There are a couple of great tutorials in docs.tigera.io. Anyway, long story short, I'm going to tell Tigera operator to install Calico with the eBPF data plane and this IP pool. And I also want the API server. Now, API server is a pod that allows you to communicate with Calico unique resources by using kubectl. More on that later. But as you can see, Tigera operator starts to install the Calico components, Calico node, which is the brain of the whole operation, data plane, and it hosts Calico node binary bird. Bird is used for BGP. Calico node binary is hosting Felix, the brain of Calico, which decides how the data plane should be operating in your environment and what are the routes, those sort of fun stuff. There are also a lot of troubleshooting stuff baked in there, which we're going to tap into. Typha, Calico Typha is an intermediary between Calico node or any Calico component that want to talk to the API server. So if you have a really big cluster, these components doesn't need to go to your API server for every request. They actually talk to the Typha pod. They get their information from there, and only a limited amount of requests, a limited number of requests are actually issued to your Kubernetes API server via the Typha pod, which then caches all the information and broadcasts it to everybody else. And a Calico API server is that glue that allows you to tap into Calico unique API resources with kubectl. Did I get everything right, Tomasz?
It sounds about right. Yeah.
All right.
Typha is primarily for scalability of large clusters, so that we don't have 10,000 nodes talking to a single kube API server.
All right. So at the moment, everything is set. If you remember, my nodes were not ready. Now, since we installed our CNI, everything is ready. Actually running everything in IPv6 mode. As you can see, these are all IPv6 because they look a little bit funny. And it's time to actually install an application. So I'm going to install the Hipster shop or Google microservices. And that's going to take a bit of time to pull the images. The internet. All right. So everything seems to be working. Let me just make sure deployment is successful. Great. So with the microservices demo, you get a lot of pods, and you also get a bunch of services. Now, the service that I'm interested in is this front and external. So this whole demo is tuned in a way that you have service load balancers. And that will allow you to actually use the external IP address in your local environment and look at the shop that you just brought up. And let me change screen. So it's online boutique. All right. So here is the online boutique or the microservices demo. As you can see, I'm using the IPv6. If you're curious about the brackets, because in IPv6 you're using columns, and columns means port. So this is going to be an IPv4 thingy. Like if you have a column, that means you're instructing that browser or whatever that's a port. So if you put it in a bracket, it will don't use it in such a way. Anyway, so let's go back to our demo and bring up on the terminal. All right, so at this point, I've got a cluster, I got eBPF working, and I have an application. So let's secure it with a bunch of policies, and then ask Tomasz about eBPF policies and how they differ from IP table ones. So here is a very simple deny all or deny by default. It's a global network policy. So a global network policy is a unique project, is a unique Calico resource that will allow you to affect the whole cluster with just one policy. So you don't need to go into all namespaces. And one of the great things about it is, unlike, let's say, Kubernetes network policies that require a namespace to be there before you can write one that can affect that namespace, these can just be in your cluster and by default deny everything. If a namespace is there or not there, doesn't matter to this global network policy, it will secure everything. Now, to make this tutorial a little bit faster, I'm excluding kube system, calico system, and calico API server namespaces. If you are following the tutorial, there's a link that shows you how you can actually get rid of these exceptions and have a specific default deny that gives you an environment that has no sort of rogue communication. Anyway, so one thing to note is that by default, everything is allowed in Kubernetes in terms of networking. When you add a policy, even an empty policy, then this behavior will change to deny everything except the policy that you wrote. Now, with Calico, you have this action, which can be the next step to say, all right, I want to say I want to have this behavior, but I want this behavior to be permit or deny. So here I'm allowing UDP inside my cluster to core DNS pods, because I don't know about you, but I'd really like to use DNS and not these funky looking IP addresses in my workloads. Now, after we do this, our shop is going to be cut off from our host or the internet if you are doing this in some sort of internet enabled environment. So what I need to do is I need to create another network policy, this time in that specific namespace, because I want to say everyone should be allowed to communicate with my front end pod. Well, this can change depending on your environment, but when you're done, everything will go back to its usual, everything is working. But the thing is, you have a default deny, which makes sure that nothing is going out of your cluster without your say so. All right. So at this point, Tomasz, I've enabled the workload and I've got the policies inside my cluster. But I want to verify if this cluster is actually running eBPF, right? So let's talk a bit about these commands. So inside Calico node, the pod, there is a Calico node binary and there is a -bpf argument that you can add to it, right? And it gives you a couple of commands. Could you please give us a general idea of what are these and how it differs from like IP tables and stuff?
Right. Yeah. Excuse me. I have a bit cough. So yeah, you can't really use the same tools as you are used to in generic Linux environment. So in generic Linux environment, you would go and explore typically with IP command, and you can do like IP route, IP whatnot. Then you have IP tables, and that doesn't quite work in the eBPF data plane because these features are implemented by different principles. Right? They do pretty much the same thing, but they don't use IP tables. They use some internal structures like BPF maps, and those can vastly differ across different eBPF data planes. So we provide a tool for some insight into the data plane. So some of the commands are really for very intimate and internal functions, and I will skip over them. But what is exciting is that you can inspect the services and how they implement that with the not command. And if you say not dump, it will pretty much dump you all the state of the data plane. Where, yeah, this is the catch, right? Like with the IP command, if you want to inspect the IPv6 part of the data plane, you have to say -6. And this is ready for the dual stack. So unless you say -6, it's going to query for the IPv4 structures. So here it gave you the whole dump. Normally you would need to go to IP tables and kind of go through all the chains that kube-proxy program I think this is a slightly more human readable format. You essentially see in the first column that a specific service IP and port and protocol are backed by some backend pods. In most cases here, it's one or two backend pods, and then you can read.
Uh-oh, I think we lost your audio. So you can see the backend pods and the target port. You can also. Are you back?
Can you hear me again? Okay.
Yes, I can.
So
All right, I got to the backend pod and the
Yeah.
target port.
Yeah, I could hear you all the time. So that's fine. Yeah, so this is pretty much gives you an overview of the implementation of services, and that's what you would get from IPWS and kube-proxy. So Reza, if you can get back to the list of the commands.
Yep, I can certainly do that.
Yeah. The next really important one is contract. And if you say contract dump, it will essentially give you the same information as the contract command in Linux, OS 6, obviously. Yeah. And that gives you an overview of what connections are currently being tracked and what connections are being forwarded to what backends if they go through a service, and some other information, whether connections are established, whether they are going to be recollected. For instance, you can see that there's a connection which is closed, so that will disappear from the table after some timeout. So if you go back to the list.
For anyone who's not familiar with contract is just a list, right? Because Linux by default is stateless, and it doesn't remember where to send back the response. We use contract to say, all right, I got a packet from source. I'm going to remember that source. When my workload is done, I'm going to send it back through that contract record, right, Tomasz?
Yeah, that's exactly what it is. It's kind of making the connection stateful, and you need to remember how did you translate the service IP into like the backend IP, and how to send the stuff back. So this is very similar to what Linux is doing. It's just that the eBPF data plane has to do it on its own, because
so these are all using eBPF maps and stuff, right?
Yes, that's correct.
Great. All right. So
probably the next interesting command is routes, and this kind of gives you more of an overview of the calico routing rather than the real routing in Linux. But essentially, what you can see here is that what IPs have what entities of your cluster, whether it's a host, whether it's local, whether it's remote. If you had an overlay, you would see whether if it's remote, whether you have to reach it over some tunnel, and what would be the next hop, and what would be the IP use there. So you can get some insight into data plane through this. And yeah, I think Reza started this question with, are we using IPv6, BPF? What we can do is to dump counters on individual devices using counters.
So I'm going to do if state. First of all,
right.
I'm gonna,
okay.
Yeah. talk about this one so we can get one of the interfaces and see the.
Yeah, this is fairly internal knowledge of the data plane, and we pretty much keep track of all the devices that have or have not their BPF programs attached. And obviously, we can't send traffic to a device which is not ready yet. It doesn't have a program attached and doesn't have a policy attached, because there will be a security hole. So we keep track of that, and you can see that we have policies loaded. Where you see the -1, it means that there is some default policy. And that depends on whether you're a pod or whether you are host endpoint, what the default behavior is. Right.
So
we can dump counters on each device to see whether we are actually processing packets. So you can do dump, and yeah, I think this dumps kind of like everything, all the devices. So you just pick whatever is yours. But what you can see is that we have seen packets, that we have accepted packets through policy. If you probably find some specific device, you could also see that we have denied packets through policy. The reason why you see way less packets accepted by a policy and then the total number of packets that pass through is that we only approve the packet that's opening the connection, right? Once we decide that the connection is allowed, all the subsequent packets on the same connection kind of follow the connection tracking information that we dumped before. And I think, so you can see that we really processing IPv6 packets, and that we actually do process packets, so we running in the eBPF mode. And I think the last command that would let you inspect the data plane, and doesn't matter whether you are in v4 or v6 mode, is the policy command, which actually can dump a policy of a specific device.
So for the policy, we need to say, since policies have ingress or egress for incoming or outgoing, we need to say which policy, right?
Yeah, you can say, as the documentation of the command says, that you can either pick ingress or egress par or XDP if you are on a host device. And you can also say all, essentially dumping all the policies on the device.
All right. So first, I'm going to need an interface. There's one here.
You can pick.
And a hook, going to be all. And 6. All right.
Yeah. So you can see that we have a policy on the egress. Sometimes it is difficult to kind of talk about the directions, because in this case the egress is egress from the pod, although that the policy is actually on the egress hook inside the host namespace. So it can be a little tricky to think about that. Yeah, and you can see that it applies the default all policy, and you get the main kind of implementation descriptions of the policy. And if you would really like to go further, you can also use the dash ASM to get the actual assembly if you really need to debug. I think it's dash. Yeah.
Oh yeah.
And then you really get the how the policy program is implemented, what it's doing, and what IP sets it's inspecting. And yes, you can also go and use the same command with IP sets dump and dump a specific IP set if you troubleshooting the data plane. So yeah, you need to kind of use different tool set, which duplicates the functionality of things that you're used to in the IP tables based data planes. But I think in many ways it's a little easier, because if you were trying to decipher the policy in IP tables, then you really need to know how to read IP tables. You would need to go through all the chains, and whether it's an forwarding chain or some in-out chain and whatnot. So I think even though it's different kind of tools, the experience might be better.
All right. And I can see my default deny policy and my default permit policy for the front end. And the actions are both here, ports, everything, protocol, the selector. That makes it really easy to figure out what's going on. Yeah.
Yeah, I hope so. And obviously, you would see different policies on different devices, like different implementation, right?
Hmm.
Because if you own a device that actually implements a backend for the front end service, then you would see that the policy allows the traffic. But if you own a device that is attached to a pod that does not have it, right, then you would see the opposite. That you you would drop everything. You may not even see the allow or permits front end at all, because they would just fall under the deny all.
Got it. All right. Thank you. That's going to be for this session. I just hit one problem, which was something wasn't installed. I guess this is like the best session ever. And with that, I'm gonna say goodbye to Tomasz. Thank you for all the explanations, and hit the end the stream on this session.
No problem. Thank you for having me, and stay tuned for the upcoming 327 release.
Yay, exciting.
Bye.